Be the change you wish to see in the world. This is a quote said by Mahatma Gandhi.
If you plot between frequency and the XL, you know that it increases like that. XL increases like that. If you plot between XC and F, it goes to infinity as F decreases, and it goes to 0 as F increases. F decreases, it goes to infinity. Here it goes to, tends to 0 as F tends to infinity. As F tends to infinity, Xc tends to 0. As F tends to 0, Xc tends to infinity. This is the plot. So, at a particular point, XL equal to Xc, that frequency is F0. If F is less than F0, Xc dominates. If X is greater than F0, F is greater than F0, XL dominates. XL dominates. F is less than F0, Xc dominates. It means its value is higher. If you see the potential drop across them, potential, if F is less than F0, potential drop across, what happens at resonant frequency? Potential drop at XL equal to potential drop at XC. They are equal. They are getting cancelled. They are getting cancelled. The potential drop across XL and the potential drop across SC are getting cancelled. If F decreases from F0, already we have seen that Xc dominates. That's why potential across Xc will increase. Potential across Xc will increase. Similarly, if F increases, potential drop across XL will increase. Potential drop across Xc will decrease. If you plot that voltage V versus voltage versus frequency, it will be like this for Xc, and for XL it will be like this. At F0, the potential drop across Xc and XL will be equal. Vc equal to VL. But from this plot, we can understand that at one particular point, at one particular frequency, say F1, one particular frequency, say F2, Xc is maximum. Vxc is maximum. Similarly, VL is here at F2. VL is maximum. How to find that? How to find that frequency at which Vc will be maximum, the frequency at which VL will be maximum. How to find that? Let us find that. Vc equal to what? I multiplied by Xc. Let us find at what frequency this Vc is maximum. Let us find first. Vc equal to Ixc. This can be written as Vc equal to I equal to what? V divided by applied voltage in a series circuit. This is the applied voltage V. Omega is varying. Resistance, inductance, and the capacitors are in series. Current through this is I. I equal to, this is Z. I equal to V by Z. So Z is what? Modulus of Z is R square, real part square plus imaginary part square. That is XL minus XC whole square. XL minus XC whole square. XL minus XC whole square. That's why need not bother about sign. XC equal to 1 by omega C. I equal to V divided by square root of R square plus XL minus XC whole square. XC equal to 1 by omega C. This is VC. But we want to find at which point the VC will be maximum. So V by Z is current V by square root of R square plus XL minus XC whole square multiplied by 1 by C. How we will find maximum? We will differentiate. So the frequency is omega. That's why we have to differentiate dVC by d omega and equate to 0. So differentiate this with respect to omega. Before that, let us write V divided by square root of R square plus omega L minus 1 by omega C whole square multiplied by 1 by omega C. So if you differentiate this d by d omega of this, we have to find. That is equal to product rule. Let us apply. 1 by omega. V and C are constants. That's why let us take them out. V and C. The C is constant and V is constant. That's why let us take outside. V by C. The remaining thing, 1 by omega, let us keep as such. If you differentiate this, what you will get is 1 by R square plus omega L minus 1 by omega C whole square to the power, square root means 1 by 2, minus 1 by 2, denominator, minus 1 by 2, minus 1, minus 3 by 2, minus 3 by 2, multiplied by minus 1 by 2. If we differentiate inside, if we differentiate R square, it is 0 because it is constant. If we differentiate this, you will get 2 times omega L minus 1 by omega L minus 1 by omega C multiplied by, if you differentiate this, you will get L. If you differentiate this, you will get minus, again minus, that's why plus 1 by omega square C. If you differentiate this, then if you keep this as such, 1 by R square plus omega L minus 1 by omega C whole square to the power 1 by 2 as such, and differentiate 1 by omega, you will get 1 by omega square minus 1 by omega square. That's why this minus. Instead of plus, why I put minus is because of this. Both are minus equal to 0. That's why we can write minus 1 by 2 omega, 2 getting cancelled, omega L multiplied by minus sign, omega L multiplied by L, omega L square. Omega L square. If you multiply omega L and this, you will get L by omega C plus L divided by omega C. If you multiply this and this, you will get minus L by omega C. If you multiply this and this, you will get L by omega C minus L by omega C. Then if you multiply this and this, you will get minus 1 by omega cube C square. These two getting cancelled. Divided by R square plus omega L minus 1 by omega C whole square to the power 3 by 2 equal to, this we can bring to the right hand side. 1 by omega square 1 by R square plus omega L minus 1 by omega C whole square to the power 1 by 2. This term and this 3 by 2 getting cancelled. 1.5 of gone, 1 will be there. If you bring this omega to the right hand side, what you will get? Minus of omega square L square minus 1 by omega square C square equal to R square plus, if you expand this, what you got? R square plus omega square L square plus 1 by omega square C square minus 2L divided by C. So if you bring this inside, what you will get is minus omega square L square plus 1 by omega square C square equal to R square plus omega square L square plus 1 by omega square C square minus 2L by C. These two getting cancelled. So minus 2 omega square L square. If you bring this to the left hand side, you will get minus 2 omega square L square equal to R square minus 2L by C. This implies omega square equal to 2L by C minus R square. I brought this, multiply on both sides by minus, and 2L square. 2L square divided by 2L square. That is equal to 2 getting cancelled. Therefore, L by C, L also getting cancelled. 1 by LC minus R square divided by 2L square. That is omega square. Therefore, omega equal to square root of 1 by LC minus R square divided by 2L square. VC will be maximum. VC max. The same way, find the frequency at which VL will be maximum.